Right, so in a 30, 60, 90 triangle, there are two acute angles, right? So here's a 30, 60, 90 triangle down here. One of the angles is 90 degrees. And then the other two are acute angles. One of them has a measure of 30 degrees. That's the small angle. And then there is a larger angle measuring 60 degrees. So two acute angles here, one small one and one big one. Okay, now each of these angles is opposite a leg. Okay? The 30-degree angle is opposite to the shorter leg. So this is the shorter leg. Okay, and we can write its measure as just one, right? 1 unit. Okay. The 60 degrees is opposite to the longer leg, and its measure can be written as how long? √3. So that is the longer leg. Now the hypotenuse is how much? 2. Okay, so nothing new there. Moving on to the 45, 45, 90, there is the 90-degree angle right there. These two are congruent acute angles, and they each measure 45 degrees. And now they're opposite to congruent legs, which means their measures can be written as 1 and 1. And then the hypotenuse will measure how much? √2. Okay? All right, now, so these, again, nothing new here. So suppose now these were actual physical triangles and I had to fit them in a specific space. All right? But suppose also that the space where I have to fit them is much smaller than this. So what I have to do is I need to shrink these triangles like you would on Photoshop. Shrink them proportionally. All right? So like literally click and drag shrink. All right? So suppose now, we call that rescaling. Suppose I wanted to rescale the triangles such that the hypotenuse is 1. Okay. Now, this one, if I wanted to scale down this triangle so that the hypotenuse is 1, right? How much smaller am I going to make this triangle? If I have to rescale it so that the hypotenuse is 1 instead of 2, how much smaller do I need to make it? I need to make it half as big, right? So I need to divide this by 2, which means this leg becomes half its size. It divides in half. And then this leg divides in half as well. So now my rescaled triangle has sides 1, 1/2 √3/2. Okay? Somebody with their calculator out, can you, okay, so 1/2 we know is 0.5. Can you plug in √3/2 and tell me how much that is? It's 0.8660. So, which one of these is bigger, the half or the √3/2? The √3/2. So you see how, again, you have a shorter side and a longer leg. 1/2 and root 3 over 2. So now, suppose now I wanted to rescale this one and make this hypotenuse a 1. What would I divide this by? What would I divide this by to make it a 1? Root 2. That means I need to divide everything by root 2. So now my new sides are 1 over root 2, 1 over root 2, and 1. Okay? Now, let me ask you this. Suppose I asked you now to use these new triangles to find sine of 30. How did we do sine of 30? It was opposite over hypotenuse. So sine of 30, opposite is 1/2. Divided by hypotenuse is 1. 1/2 divided by 1, how much is it? 1/2. So do I really even have to divide by the hypotenuse anymore? Because it's just divided by 1, right? Cosine, it would be adjacent divided by hypotenuse, but it's divided by 1. Do I need to divide by 1? That's silly. Why would I divide by 1? So, you know how it used to be SOHCAHTOA, where it was opposite over hypotenuse, adjacent over hypotenuse? Now that the hypotenuse is 1, and I'm only dividing by 1, I could just get rid of those H's. So instead of it being SOHCAHTOA, it's like SOHCAHTOA, right? So it's just sine is opposite, not opposite over hypotenuse, and cosine is adjacent, not adjacent over hypotenuse. You see why we did it? Because it makes it a lot more efficient in what's coming later. Okay? So no more of this dividing by hypotenuse business. These, secant. Yes, what about secant? Secant is, okay, so cosecant for sine. So sine of this is what? 1/2. Cosecant, the reciprocal of this, so just 2. No more of this business.
Oh, no.
No, I don't have to. So because the sine is 30 of 30 is 1/2, the cosecant is just this, the reciprocal, 2. Right? This, the reciprocal, 2. Okay? Okay. So now, so this, right? This triangle that we had before in geometry, this is like old school now. We don't use it anymore. Like this was so 2 years ago, right? No more of this triangle, right? I was telling the other class before, this is like Facebook, and now we've got like TikTok. So no more of this stuff. You see what I mean? Like no more. This is so outdated. Like who does this? Nobody. Just the geometry people. Okay? Right? Okay. So that's what we're going to do now. So we're going to use this method now. Okay. Okay, one other thing I want to do is solidify in our minds, finally, this whole radian business. Okay? Remember how back in the day, like a week ago, we said 180 is the same as pi? Okay? Okay. So now, suppose I have 30 degrees. How do I get 30 degrees? What should I divide 180 by in order to get 30? 6. So we can all agree. I take 180, divide it by 6, and I get 30. Okay, if 180 is the same as pi, then all this is the same as pi divided by 6. You see what I mean? Let's say that again. 30 is 180 divided by 6, or pi divided by 6. So whenever I think pi over 6, I'm like, oh yeah, pi is 180 divided by 6. That's like 30. Okay? 60. How do I get 60? 180 divided by what? 3. If it's 180 divided by 3, that's the same as pi divided by 3. Okay? So these two you should know, right? And you should also know, like if you're walking down the street and you see on a billboard, you know, like there was a billboard and it just says pi over 6. That should register as, oh yeah, that's the smaller angle. Pi over 3, that's the bigger angle. So, how can we reason that out? Suppose you have a chocolate bar. What's 1/6 of this? Is it a small piece or a big piece? 1/6 is a small piece. Okay? Now, suppose you have a chocolate bar. So that's like pi over 6 here. Suppose you have a chocolate bar and now you want 1/3 of it. That's a bigger piece, isn't it? Right? So divided by 6, tiny piece. Divided by 3, bigger piece. Smaller angle, bigger angle. Okay. How do I get 45? 180 divided by what? 4. That's the same as pi over 4. Okay? Now. All right. I got sine of pi over 6. So first you need to ask yourself, pi over 6, is that the big angle or the small angle? Small angle, that's this one, isn't it? Yeah. I want the sine. I just said sine from now on is just opposite. Opposite, how much is the sine? 1/2. So sine of 1 over 6, pi over 6, 1/2. All right? More efficient, more quick on our feet now.
Why is it just the opposite?
Because it used to be opposite over hypotenuse. So this divided by this. But now that this is 1, I'm saying, 1/2 divided by 1. But divided by 1, you could skip it, right? So that's what we just skipped that part. We just say it's that, right?
I just don't understand why like divided by 2.
Because later on when we start doing the unit circle, we're going to need all of our triangles to have a hypotenuse of 1. The other way is not going to work anymore. Plus this makes it more efficient. So it's just sine is opposite, cosine is adjacent. That's it. Okay, so now cosine of pi over 4. Which angle is that?
It's the 45.
The 45. Cosine is just adjacent, so it's 1 over root 2. Okay. All right. Cosecant of pi over 3. Which angle is the pi over 3? 60. Cosecant, is that like sine or cosine? Sine. Sine of this is just the opposite, root 3 over 2. So what's cosecant? 2 over root 3. Okay, now, cotangent of pi over 6. Where is pi over 6? Big or small? Small. Cotangent is adjacent over opposite. Adjacent over opposite. So adjacent is root 3 over 2 over opposite 1/2. So now it's the first fraction divided by the second fraction, which is times the reciprocal of the second. You can also do that. You can also do that. You could also do that, and that's perfect. Okay, if you guys know to do that, no, but do you know why you're canceling 2, or you're just doing it because Max did it?
No, because it's 2, so
it's 2 root 3 over 2.
Okay, so this is root 3. So look, this is a fraction. So look, I would rather you do it the canceling way. So look, fraction divided by a fraction. The denominator on top is a 2. The denominator on the bottom is a 2. If they have identical denominators, you can cancel them. So now this was still the main fraction. On top, I'm left with root 3. On the bottom, I'm left with 1, so it's still root 3. Okay. Now, if you run into trouble with that, come see me and we can go over it. Okay, now let's talk about the unit circle. The unit circle is a circle of radius 1 centered at the origin. Okay, now we can label this with the special angles as we've always talked about. So first, let's do the degrees. Okay? So look, this first line is 30 degrees away from the origin. Okay? Hey guys, I'm fine with you guys sitting wherever you want to sit. You just have to be responsible about it and not be chatting. Okay? Because that I take personally. Because you know what? I'm giving this all I got, and you need to give me all you got. Okay? Otherwise, I will make a seating chart. So, so it's 30 degrees up from the x-axis. So now if I go here, 30 degrees up from the x-axis, that's this one, and that's 150. Now, if I do 30 degrees down is 210, right? So what's 30 degrees down from here? From this x-axis? This way. 330. So these are all the ones that correspond to 30 degrees. Okay, now let's do the 60 degrees. This one is 60 degrees from the x-axis. What's 60 degrees here from the x-axis? 180 minus the 60, 120, right? 60 away. Here, 60 away from 180, 240. 60 away here, how much? 300. All right. Now, what about the 45s? So this is 45 degrees from the x-axis. 45 degrees from here is to, how much? 135. So we always measure from the x-axis. 45 degrees down, 180, 225. And then here, 45 degrees down from the x-axis, 360, 315. Okay. So these are, so the blues are all corresponding, the reds are all corresponding, and so on. Now let's do the radian. Believe it or not, after a while, students always come and tell me, you know what? Radian is easier to work with for me. And that's always the case. That's true. So once we lay it down, I think you'll find that radian is easier. Okay, so so let's talk about pi over 6. Notice, by the way, all the 45s end in 5 on the unit circle, right? And then it also works the other way. All of the ones that end in 5 on the unit circle are the 45 degrees. Okay? Okay. All right, so let's go with radian. Let's talk about pi over 6. Pi over 6 is like how many degrees? 30. So this one here is pi over 6. So this is like all the red ones here. Now, the way we label, so there's going to be 4 of them. And the way we remember their values is, this is 1 pi over 6. And now I keep increasing the coefficient. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and so on. So 2 pi over 6, do the 2 and 6 cancel with each other? They do. So I don't like it. I throw it away. 3 pi over 6, does it cancel? Yep, don't like it. 4 pi over 6, don't like it. 5 pi over 6 does not cancel, so this next one is 5 pi over 6. 6 pi over 6 reduces, throw it away. That's how you do it. Yep, 7 pi over 6 is this one, because it doesn't cancel. Then look, I have a long way to go. 8 pi over 6 cancels, 9 pi over 6 cancels, 10 pi over 6 cancels, until 11 pi over 6. Okay, so basically you just need the ones where the 6 doesn't cancel out. Yep.
What was like
13 pi over 6, so 12 pi over 6 is 2 pi, and then 13 pi over 6 you go back. That's 2 pi and 1 pi over 6, so it goes back, yeah. Okay, so that's how I do it. That's how even me, I do it. I go, okay, pi over 6, 2, 3, 4, 5 pi over 6, 6 pi, 7 pi over 6, and then the next one, 11 pi over 6. Tati, question?
Oh wait, is that 7 pi over 6?
Yeah, bottom left, 7 pi over 6. So you see how? So don't memorize it. Like, I don't even want to catch you memorizing this stuff because it's useless. But you just know the pattern and then you figure it out with the pattern, okay? So let's do a pi over 4. That's like the blue here, right? So this is pi over 4. And now I say, okay, 1 pi over 4. 2 pi over 4 cancels, throw it out. 3 pi over 4 doesn't cancel. 4 pi over 4, no good. 5 pi over 4 is good. 6 doesn't work. 7 pi over 4 is good. And if you notice, with every single one, if you go one more, what's 8 pi over 4? 2 pi, right? Full circle. So next is the pi over 3s. So like I was telling the other class this, let me plug this in. So I've had my car for several years now, right? I know exactly where everything is in my car. I know where the hazard button is in my car. But one time I got into an accident. It wasn't even a major accident, but I got into an accident. I was so panicked and like freaking out and like my heart pounding. I couldn't even find the hazard button, right? So that's what happens when you're in that stress. And a lot of you guys get that way when you're taking a test and you're rushed and blah, blah, blah. So if you've memorized this, it goes away. You can't ever find it, right? Like you have no idea. But if you know the way to figure it out, then it will always stay with you, okay? So, pi over 3, right? Pi over 3, that's the 60s in here. So this is pi over 3. And then again, 1 pi over 3, 2 pi over 3 doesn't cancel. 3 pi over 3 does. 4 pi over 3 doesn't cancel. 5 pi over 3 doesn't cancel. What's 6 pi over 3? 2 pi. You see that? I know, yes. Okay, so here too, we end with 11 pi over 6, and then what's 12 pi over 6? 2 pi. Okay, so when I teach algebra 2, or when you know, in algebra 2 or even in intermediate, we end with trig. I do this in algebra 2, but I bet the first time we do it in algebra 2, it doesn't make as much sense as the second time you do it, And that's how trig is. It takes a couple of times going through it to make sense. Okay? So, the moral of the story, if there's one thing I need you to take from this, don't memorize. Figure it out like this. Okay, so now, back to here. Okay, go back to this page on your notes. Go back to this page because I don't want you to see the other pages. Okay, so now suppose I want you to place 5 pi over 6. Where is it? Pi over 6 is the tiny angle, right? So it's these. Okay, it's the 30s. So 1 pi over 6. What's the next one? 2 pi over 6, 3 pi over 6, 4 pi over 6. 5 pi over 6 is this one, right? Top left. Okay, so that's how we do it. So 5 pi over 6. All right, so what if now we have, okay, let's put in 7 pi over 4. The pi over 4s are which color? Here, blue. So where is 7 pi over 4 going to go? This is 1 pi over 4. Then, what's this one? 3 pi over 4. 5 pi over 4. 7 pi over 4. Isn't that fun? You could do it all day. The next time, who would have thought? The next time you're at the beach and you find yourself with nothing to do, all you have to do is draw a circle in the sand and label the angles in radian, right? So, how about 4 pi over 3? 4 pi over 3. Yep. Jason.
Okay, so pi over 3 is green.
Right, let's listen up. Pi over 3 is green.
And so we've got 1 pi over 3. 2 pi over 3. Okay, 3 pi over 3. Is it 240?
Yep. 4 pi over 3. So 1 pi over 3, 2 pi over 3, 4 pi over 3 right there.
I know what 7 pi over 6 is.
Tell me.
It's what 210 is.
7 pi over 6, is he right?
Yeah.
Yes.
1 pi over 6, 5 pi over 6, 7 pi over 6. So then, what's the 120? Without looking back, what's the 120? Is that a pi over 3 or a pi over 6?
Pi over 3.
So which is it, the 120?
2 pi over 3. Oh.
3 pi over 3 goes away, so 2 pi over 3. So in the first, and you notice there is only 1 in each quadrant. So 1 pi over 3, 2 pi over 3, and then 4 pi over 3. And what's the 300 then? 5 pi over 3. It's like endless fun, right? So now look, you could even go further. Okay, so this is pi over 3. Look, guys, look up here. 5 pi over 3. I'm sorry. 1 pi over 3. 2 pi over 3. 4 pi over 3. 5 pi over 3. Now let's go further. 6 pi over 3 cancels. 7 pi over 3. 8 pi over 3. 9 pi over 3 cancels. 10 pi over 3. 11 pi over 3. What's 12 pi over 3?
Cancel.
How many though? 12 pi over 3. 12 pi over 3. 4 pi, which is here. We went around once already. See that, like, you could do it until you get to like 211 pi over 3. Of course it makes sense. It's math. It's got to make sense. Last year, yeah, you memorized it, and then how much of it did you remember this year?
330, 11
330 is 11 pi over 6 because 12 pi over 6 gets you a full circle.
It's counting as memorized.
I know how many of you guys memorize it. I hate that word. I hate that
We
word.
did around the world like every day for